Hello and good evening, everyone. It's a great pleasure to have you all here. So this is the before we start, I want to say a couple of words, especially what happened. So actually, in a few days, 10th of December next month, we have our first anniversary. We basically 1 year old, this meetup, 12 months. In these 12 months, we have had already over 26 meetups. And since this morning, I counted 1,200 plus members across Zurich, Geneva, and now as well Basel. So I think that's pretty impressive because for 12 months, meetup, people that interested in blockchain, that's quite cool. So I would like to say a couple of thank yous because there's lots of people that actually been involved in this meetup group, specifically over 3 cities. It's a lot of work actually to get things like this done, and we are very happy and glad to have sponsors. They help us make this possible, and of course have these people. So I would like to thank first of all Swisscom, who is our sponsor. David is here tonight. Thank you, David, for the sponsoring of the event here in Zurich. As this is recorded, say thank you to the fintech guys in Geneva, Fusion. They are hosting the event there. Specifically, I have to thank Cyril Laptin, who is the co-host in Geneva. He does a fantastic work organizing the catering, doing the events when I'm not there. So I just wanted to say a few words to them. And then, of course, I have to thank all of you. I mean, you're just a small representation of the 1,200 people across the cities here. But I think without you having an interest, this whole community growth would not make any sense. So thank you to all of you for coming. The usual upcoming events. So we have a great guest tonight here. Trent is also going to be in Geneva tomorrow. On Thursday, for any one of you who might be in Basel, we actually, as we started last month with the Basel site, introducing Colony and had to stream. We had some technical issues, I know. We tried this whole live stream thing in 3 cities. I apologize for the technical issues we had there. It was the first time I've used an open source tool, so it wasn't 100% great, but most of the people understood everything. So in Basel, we're going to have my co-founder, Dr. Sebastian Bürgel. He's going to give an introduction to blockchain, so if anybody is interested around. We're also going to introduce a new game that we developed for educational purpose. You can actually win Ether, so it's going to be a fun gambling tool. December, I will announce them soon. We had something planned in the NGO space. Unfortunately, that has been postponed to February next year. We've been here last weekend. Just want to say a couple words to the hackathon. We had a hackathon in blockchain endurance tech last weekend. We had about 37 hackers here, 2 endurance companies supporting future ideas of endurances in the blockchain. Was pretty cool. And the reason I'm telling you that, because if you didn't come here, and I don't see some very familiar faces, you have another chance in January. There is another hackathon coming up. It's sponsored by Thomson Reuters, 27th to 29th of January. It's the Hack the Valley. We will be informing you guys about this, more details in the next couple of days when the site goes online. And you can sign up if you want. So it's going to be also endurance, legal, and media. So it might be quite interesting for you guys. Before I'm going to start now introducing the speaker, I think Ali from Swisscom would like to say a couple words.
Yes, thank you. Hello, everybody, and also a warm welcome from my side. My name is Ali Soy. I'm working for Swisscom in the area of Internet of Things, Business Development Manager. BigchainDB and IoT, this was also something what I looked at it. And when I started to explore blockchain technology, it was I was also already in the opinion that I can use blockchain technology also for IoT and mass data and so on. And I realized really very quickly that the technology of blockchain only is not the right way to store a lot of data, and also because of the latency of the time for a lot of transactions from the IoT devices. So I'm very happy to have you here and explaining about the BigchainDB and what the possibilities are there.
Thank you very much. In general, it's really a pleasure to be here, and so I appreciate that each and every one of you took the time to come here tonight. So thank you once again for coming here tonight to, let's see, great, to be here. I'm Trent, and I'm going to talk about BigchainDB. Yeah. I'm going to talk about whatever appears on there next, which is, I'll just get started because it's simpler. Let's see here. So today I'm going to talk actually about a couple things that are very related. A public database for the planet. It's going to have pieces of BigchainDB. It's going to have pieces of IPDB, the Interplanetary Database. And let's get started. So, you know, I like bananas. Probably lots of you too. Imagine if you went into a supermarket and you go to the banana section, you're hungry, you grab a banana, and then you walk to the checkout, you look around, and there's no checkout. There's no one working at checkout, there's not even a checkout. You're like, that's weird. It's not how supermarkets normally work. But okay, I guess I'll pay next time. So you walk out of the supermarket with your banana, you start walking down the street, eating your banana, wondering how you pay. And then suddenly, a 500-pound security guard jumps and tackles you and says, that will be $5,000 for that banana, please. Sounds ridiculous, right? Guess what? This is the internet today, the web today, to be precise. If I go and I want to use an image, I might find it online. If I can right-click copy, and if I use it, well, that's actually, I want to pay for it, but it's very, very hard for me to find the creator, to license it, to use it, right? Why can't I right-click copy? And this is actually a big problem with the internet in general, right? If I put my works online, and I want to get paid, it's actually very hard unless I go into some centralized silo like Getty Images. And this just isn't just images, this is music, this is video, this is all of the things. So basically, the World Wide Web itself has been very good about transmitting data, media, and so on, but it has been terrible at compensating the creators, about helping creators to pay their families. Not only that, most of us have been users of Facebook and these other social networks at some point of time, or Gmail. Well, guess what? Each one of these, of course, is its own silo, right? There's the classic saying, if you're not paying, you are the product, right? And that's very true. So each of these social networks and other centralized providers are making you the product, and they're siloing up your data, right? They're making a fortune from it, billions, hundreds of billions of dollars, right? You're getting some value because you have a phone book, but you're giving up a lot. There's a good way to summarize this when it comes to your personal data or your creations. Someone on the Shapeways blog, it's a 3D printing marketplace, gave the quote, "My conclusion is that whatever you put on the internet, you lose it. Maybe you keep the rights, like copyright rights, but you lose the power over it." So you could summarize this challenge overall as the current systems of power on the web, but even beyond, you can generalize, they're creating unequal outcomes. This is actually a problem for society overall, right? And we've just seen that very recently with some of the symptoms with the recent elections and the Brexit and all that. A couple of big examples are on the creative works are backwards, I've talked about. With other stuff, it's really hard for you to use other stuff legally and pay dollars. And with your stuff, it's hard not to lose. You put it out there, you lose it, basically. And your data isn't really yours. You've got these walled gardens, right, where you can't share how you want, and these data silos. If you want to leave, you can't take your data with you, right? A friend of mine actually tried to ask Facebook to give him all his data, and he actually had iterated with Facebook for months and months, and finally they sent him a giant stack of a printout of his data like this. He never ever got the electronic data, right? So yeah, and he's a lawyer, so he really pushed them hard, but the average person, no chance. So let's ask, is there some sort of solution to this, right? some sort of solution towards a more equitable society overall, manifested in the web, in the internet, and more broadly, where creativity is encouraged, where creators get fairly compensated, the digital artists struggling to feed their family, the cultural commons is protected, so we still have a vibrant commons out there where we can actually use data that is public domain and so on. And at the same time, your identity is yours. You're owning your own personal data. You're managing your reputation. You choose what to share and what stays private. So your personal data is sovereign. And more, right? There's, as other examples of manifesting here, equal opportunity for banking, right? Why is it that there are billions and billions of people that can't get bank accounts? I think the count is 4 billion or 5 billion. And knowing where your atoms come from, when you take that drugs from that bottle, do you know the provenance of the drugs? What about that beer that you're drinking, right? Maybe that came from a sewer down the street. You don't know, right? So, sorry, I hope I didn't ruin that for you. So overall, though, really, there's a lot of opportunities for a more equitable society with creativity, with identity, with banking, with atoms and supply chain and all of these things, right? So the question is, how do we get here with sort of this as definitions at sort of a higher level, right? So let's drill down and think about it. And obviously I come from the world of computing and all that. I actually spent 20 years as an artificial intelligence researcher doing a lot of big data, a lot of machine learning for the enterprise and otherwise. So, I played around with a lot of processing and I'm a geek, all this sort of thing. So let's drill down into the compute side of things a bit. So if you look at traditional compute infrastructure, there's really a core. The core of computing itself is processing, storage, and communication, right? That's the three elements of computing. And that manifests itself in a stack like the following. At the very bottom, you've got the communication, so connecting networks, TCP/IP, for example, right? And then the storage comes in two flavors. You've got the file system, and you've got the database, right? A file system might be blobs of data on S3 on the cloud, for example, or maybe some crazy big data file system like Hadoop file system. And then databases, right? This is things like MySQL, the relational databases, or MongoDB, one of the prominent NoSQL databases. And then processing, things like EC2, all this. A platform on top, like Amazon or Azure. And on top of that, you've got your applications, right? Whether it's Netflix or Facebook and so on. So this is really useful to understand. And you might look at this like, of course, Trent, I know that. That's super boring, right? But you're going to see that this traditional infrastructure has a very big importance towards what we're looking at with decentralized. So take heart to this. And in particular, let's take heart to the storage. There's really two types of storage mechanisms there, right? They're quite different. File systems are really good at storing large media blobs, and they're organized as a hierarchy of directories and files, right? But if you want to query saying, hey, I want a list of all the males over the age of 40 who started a crypto startup in the last 5 years, that's going to be very hard and very slow to search through a bunch of files, right? That's where a database comes in. And imagine if you could specify that sort of query in one single line in a unified language. Guess what? That's exactly what SQL and other query languages are, right? And this research goes back to the 60s and 70s. That's the essence of a database, is querying. Without querying, you have a CSV file, right? So a database basically provides the opportunity for querying, and then modern distributed databases actually allow you to do it across multiple machines at once. So distributed querying, all of that. So this is traditional compute infrastructure. Nothing fancy, but really important to emphasize that databases are a thing. Now, towards this more equitable society then, we've got this traditional stack. And ideally, we have a shared global compute infrastructure, right? The Ethereum folks like to call this a world computer. I love that label too. I made it more of a mouthful for fun. And what are some of the pieces though, right? There's the decentralized part. No single entity owns or controls this infrastructure, or even pieces of it. Self-sustaining, so it doesn't go away. Planetary scale, right? Web scale, internet scale, all of that, right? So, for example, right now, I'm actually talking faster than the Bitcoin network. The Bitcoin network is actually, it starts choking up at 1.5 transactions per second, right? Theoretically, it's 7, but it starts choking up at 1.5. I know, we used to build on Bitcoin back in the day. So, if you really want to have an app that takes off at the level of Twitter or Facebook and so on, then you need to start going at scales much higher. A simple example of IoT, right? Let's say you've got an IoT power meter, or just a regular power meter, with 50 million people in your nation. You're reading from a reading once every 1,000 seconds per meter. That gives you 50,000 transactions just for reading power meters, right? That's out of the box, right? Or, Twitter itself, actually, we're talking about 5,000 to 15,000 transactions per second. A really bad ad network is 100,000 transactions per second. A good one, 500, right? Global email, by the way, is 3.2 million emails per second. So, sorry, 3.2 million. So it gives you kind of a feel of what's out there, right? So when we start talking about 1.5 transactions per second, this isn't 1.5 thousand or 1.5 million, it's only 1.5. That is not planetary scale, right? So overall then, these are some of the pieces that you might need. Now what's cool is we can start saying, what about a decentralized compute infrastructure? How do we get there? Because to meet these specs back here, these are some of the things we need. We need decentralized, self-sustaining, planetary scale, and all the pieces, right? The file system, the processing, the database. And Bitcoin started to show us this at the very beginning. So when Bitcoin came out, it really was a very cool invention in a computer science sense, right? It was the very first database out there that not only solved fault-tolerant consensus and Byzantine fault-tolerant, it also addressed the Sybil problem all at once, right? And no one had actually done this in a practical way before. Another way of looking at it is it actually solved the cap theorem for you nerds out there using crypto-economic constraints. So it's kind of very cool. So you could say that you can use it as a database, right? And in fact, where we started with Ascribe, in the summer of 2013, this is exactly what we did. We pretended that Bitcoin was a database, and then we used it to timestamp artists claiming attribution and licensing. And it was okay for getting going and thinking about things. Of course, I mentioned issues of scale and so on. But as we learned more about it, we realized by traditional database standards, Bitcoin is a pretty terrible database. It's slow in throughput. They call it bloated, even though it only holds 50 or 70 gigabytes, right? My thumb drive holds more than that. That's not planetary scale, right? The latency is terrible, right? To have a single write is 10 minutes, and to have 6 confirmations is 60 minutes. And by the way, that's still not consistent in the finality sense that you expect in the cap theorem. So by traditional standards of databases, Bitcoin is terrible. But it was really cool in some new ways, right? It was a whole new type of database, a blue ocean database, if you will, just like the NoSQL databases of the past or graph databases. What was cool? For the very first time, you could have decentralized control. So instead of one single entity controlling that database, it could be a whole bunch of entities. Spread across the planet, basically, it's like a public utility then, right? The second benefit was that you had a much greater degree of immutability. In my view, nothing is absolute with respect to immutability, but it really was much more towards the idea of once you write it, it's as if you've etched it into stone. And the third thing that was very interesting about Bitcoin was the idea of native assets. Once you create and issue an asset, you own it if you have the private key. And you can transfer that asset to someone else if you, by basically, you're the only one who can transfer it because you have the private key. And so you can view it, from a database perspective as document level permissions, but in a very specific way, right? And this allows you these native assets to flow around in the system, right? So to summarize, Bitcoin showed that you could have this new type of blue ocean database with these new characteristics, decentralized, immutable, and assets, and that made it very interesting, even though, like I mentioned, it wasn't so great by traditional standards. So Bitcoin, in my view, still has a place. You could say it's a database, but I think it's better to think of it as eGold or eCash. I'm not going to dive deeper into that argument. I know there is one, but something out there related to some sort of electronic currency, right? So that leaves all these other components out there that are looking to be decentralized, right? Towards a decentralized compute infrastructure, which can help society, has the promise to help society in many ways. And we've seen a flowering, actually, in the last couple of years of the different pieces getting filled in. So the first that came out, most prominently, was Ethereum. And you can view that as decentralized processing, right? Smart contracts is basically decentralized processing. You can subdivide it further into decentralized business processes as well as large-scale processing. And the large scale might be Golem or something then. But really, that's really where Ethereum fits the best, right? And of course, more recently there's been Hyperledger project, which is also for decentralized processing, the Fabric and Sawtooth projects at least. For the platform, one of the earliest is Eris work with Tendermint. And really these platforms are sort of this overall software system that captures many things. For the file system, the most prominent one out there is IPFS, Interplanetary File System. There are more as well, right? IPFS is more like an organizing file system. There's actual data level storage, like STORJ storage. There's also Ethereum Swarm, there's Swarm.js, there's more. So overall, there's these new components that are emerging. Oh, and oh yes, one more on the interoperability side. TCP/IP, you can view that as a way to connect different networks for data. But as these networks connect, it does not sell double strand, right? Some packets can go this way and that way. But Interledger came along and actually is essentially TCP/IP for value. So it's a very exciting protocol that is emerging. And I think it's very healthy to view Interledger as a TCP/IP for value. So overall, we've got these different pieces. But there's a missing piece. And it's a big missing piece, right? Have you ever written a web app without a database? It's really hard. You can use a file, but it's going to become, or a file system, but it's going to become a big mess very quickly, right? Or have you ever hacked on Bitcoin or Ethereum and found yourself waiting and waiting and waiting to do any queries? Waiting minutes, waiting hours? It's pretty painful, right? Or maybe just saying, you know, maybe you're a music company and you want to register the 30 million songs that the top 3 labels have, right? Try putting that into Bitcoin one at a time, and you need it one at a time for provenance. Well, at 10 cents a transaction, that's how much Bitcoin costs. It'll cost you $3 million. Or, like we did on Ascribe, we actually indexed the web. We crawled the web and indexed 15 billion images. We actually would have loved to do the attribution on that, timestamping of these sightings. But that would have cost $1.5 billion. Our investors wouldn't have liked that very much. So overall, the point is there is a big hole in the decentralized ecosystem. And that hole is databases, right? A way to store persistent state at scale. A way to do transactions at scale where the interface looks, acts, feels like a database. That's what I'm going to talk more about today. It comes in a combination. BigchainDB is the database software. And we also have a public network called IPDB. I'll talk about both. So overall, the elements of a planetary scale database is 2 things. The database software, once again, combining the best of traditional databases and blockchains. This is BigchainDB. The second thing is a network running the software with thoughtful governance. This is IPDB. So I'm now going to drill into both, one at a time. So first of all, BigchainDB. So for these slides, I'm going to use a bit more of the BigchainDB colors because, I don't know, just to mess you guys up, maybe send you into spastic attacks, I don't know. Overall, though, so databases, right? Everybody uses databases. This is just a core foundation of the modern compute stack, right? Because you need storage somehow. Once again, it comes in 2 flavors, file systems and databases, right? There's an interesting thing that happened in the world of databases. You know, in the 70s, when they were first developed, it was the relational databases, SQL, etc. This is the house that Oracle built in the 80s, became a multi-billion-dollar corporation. And then, you know, in the late 90s, as web started to grow like crazy, people were finding that speaking the language of the web was hard, and they wanted to get to larger scales yet. So they started using distributed databases. They started making these a lot better, right? And in the early 2000s, there was things like Apache Zookeeper that came out, and other stuff inside these big companies like Google. And by the mid-2000s, this stuff had become open sourced and more available to all. And this is where things like Cassandra came out. That's a distributed database originally developed at Facebook. And MongoDB, etc. What is the difference between distributed and decentralized? Distributed means that there's more than one machine helping to do the computation or the storage. But you could still have centralized control or decentralized. But distributed is about the resource sharing across multiple physical machines. Whereas decentralized is about control, right? So in decentralized, no single entity owns or controls the overall network, right? So a distributed database is spreading across many machines in order to handle scale, right? And people might, you might have heard here and there that Satoshi invented consensus. Well, that's entirely not true. Consensus algorithms actually have a long history. How do you think the ARPANET synced up when they were rolling it out in the mid-50s? And there was big advances in the 80s and 90s out of Microsoft with Leslie Lamport, out of MIT with Lizgov and Castro, and so on and so forth. And this is actually the core of these distributed databases. If I put a value of x equals 7 into one of these databases, how does it sync up? Well, this is the consensus algorithms, right? So overall, the summary is there are these big data databases. They're out everywhere, and they have their own consensus built in. And with that consensus, this is how the multiple nodes agree on a singular value. One other thing that's really important, these things scale like crazy, right? So this plot here shows the x-axis is the number of nodes, the number of physical machines, and the y-axis is the throughput, the writes per second. This is Cassandra in this case, on an experiment that Netflix did more than 5 years ago now. And with 50 nodes, 50 machines working in parallel, it could get to nearly 200,000 transactions per second, right? By the time you got to 300 nodes, it got more than 1 million transactions per second. And you might ask, well, how is that possible? And it's because each node is actually taking a fraction of the incoming traffic. And then it's sorting out how to order these and so on. But this is really cool, right? So as you add more machines, the network actually gets faster, right? It's storing more too, right? The capacity goes up. And by comparison, by the way, pretty much every single blockchain out there hugs the x-axis, right? Because, yeah, you see like the bottom rung is 200,000 transactions per second. I'm actually hopeful for all the other pieces of the decentralized stack, doing processing, etc. There's a lot of cool work that's happening. It's going to get there. I'm excited for it. But there's still a lot of room for leveraging a database. And the cool thing is, because people have done upfront hard work on these distributed databases, we could ask the question, how do you decentralize a database? And so what if you had a decentralized database? What if you could start with one of these distributed databases that works really, really well, right? So start with one. Start with like MongoDB, for example, right? It's got tons of enterprise customers. For example, here, this is some of the select customers of MongoDB, right? Amazon, Viacom, Disney, Visa, Citi, MetLife, PayPal, Bloomberg, et cetera, right? This is actually the fourth largest database in the world in terms of revenues, and the three above it are actually traditional SQL databases. So MongoDB has one. It's basically the de facto standard for NoSQL databases. So start with MongoDB, and then from that, you engineer in the characteristics of what makes a blockchain. And you have to be opinionated there. And we distilled, after our experience with the Scribe, I bought Bitcoin in 2010, followed this space a long time. I see that there's 3 characteristics that I mentioned before, right? Decentralized, immutable, native assets. So to engineer in the decentralized, you say each one of these nodes that was traditionally distributed and controlled by the same sysadmin, now you have a different sysadmin, a different controller for each node, okay? That's step 1. Step 2 is for the immutability, which leads to the benefits of audit trails. You hash on the previous blocks, the classical blockchain approach, a Merkle chain, if you will, and make it leverage more of the append-only capabilities. So classical databases, they follow this CRUD philosophy, C-R-U-D, which is create, read, update, delete. Basically, you get rid of the UD part, right? So a blockchain is essentially CR, right? And then finally, native assets. So here, the asset, you own it if you control the private key, right? And of course, you can get fancier with multi-sig and combinations of multi-sig and so on. But overall, it's this notion that you own that asset if you have the private key. And you can only really do that if many, many parties control it, because otherwise someone can go in there and delete things, right? And then the asset essentially lives on the database, right? So this is actually how you engineer this. This is exactly how we engineered BigchainDB. We started with RethinkDB for some smaller technical reasons, and now we are actually in the process of converting everything to MongoDB. We are MongoDB's only blockchain partner, so we're working very closely with MongoDB. We have been for several months, actually. So BigchainDB, the architecture, is in the very center is the traditional distributed database, MongoDB or Rethink. And it has its own consensus. It solves ordering. That's the essence of consensus. And it's actually fault tolerant. So if there are crash faults, it handles them, right? And then what BigchainDB adds above and beyond that is an extra degree of tolerance to handle double spends. That's really the main thing, right? So that if I send, if I have $10 in my wallet, I send $10 to you, and I send $10 to you, well, it will complain, right? And it should. So basically, that's the core. And then it also addresses other faults that are more malicious in behavior. So that's really the essence. Now notice here that there is a server-side architecture. It's a server and client architecture, right? So it's not decentralized peer-to-peer. It's not server-free peer-to-peer. It's server-based peer-to-peer. Sorry, it's server-based decentralized rather than server-free decentralized. So notice that in the center, there's this cluster, these pairs of BigchainDB and these containers. So there is that cluster that you talk to, and then there's clients like Alice and Bob, right? Did you know that one of the names is actually Trent? By the time you get to T in crypto land, it's Trent. I like that. Anyway, overall though, so this is actually key to note that you could have 20 server nodes, you could have 100 and so on, each one controlled by a different entity. But it's a different paradigm than saying, okay, we're going to have 20,000 nodes out there where each person is both the client and the server, right? And in a sense, this is how practical public networks work anyway, like Bitcoin and Ethereum, because people have these light wallets, SPV wallets, etc. And you could say that the main server nodes in Bitcoin and Ethereum are really the miners or the mining pools, right? The 5 dudes in China that run Bitcoin, for example. So overall then, BigchainDB you can think of as a combination to try to merge the best of traditional databases with blockchain characteristics. So it is through and through a database, right? It's trying to be a database. It's leveraging best-in-class distributed database. And then it's bringing these characteristics. So it's immutable, decentralized control, and native assets. But from the database, it gets the benefits of scalability. And that's in terms of storage capacity. That's in terms of throughput. That's in terms of low latency in queries, in reads and writes. There's also the queries themselves. And by the way, this is hard. When you actually have data spread across 100 or 1,000 nodes, guess what? Doing distributed queries is hard. If you read a textbook on distributed databases, like one of these 1,000-page textbooks, 500 pages will be on the distributed query. So it's actually a hard problem. And finally, operationalized. So we make a point of leveraging this code that MongoDB has been refining over the last 9 years. So that's BigchainDB. The other part is IPDB. And I'm very excited about this part. What led us to building BigchainDB and IPDB is we started with a scribe, right, which was IP on the blockchain. We started with Bitcoin, trying to compensate creators for the globe. We ran into issues of scale, which is what led us to BigchainDB. But because of this, all along we said, okay, there needs to be a public network for BigchainDB. We knew that from day one before we started work. And so as we were engineering BigchainDB, at the same time we were taking steps to line up IPDB. And we realized that there would be the actual network, the physical manifestation, but there would also need to be very good governance, right? And what would that look like? So we were thinking about this even a year ago. So some of this, and I'll get to both of these pieces, the network and the governance. So this thing is designed for everyone everywhere. Anyone can read, anyone can write, all that sort of thing. It's priced just like any web software as a service. So if you're a web developer, you want to go and use Heroku or Stripe or something, then maybe the first 1,000 transactions are free, and after that you start paying, right? Well, this is exactly how IPDB works too. And in a sense, it's not that much different than something like Ethereum or Bitcoin, where you have to pay fees for dust and this sort of thing, right? So there's always fees to the miners and so on. In this case, you pay simply like you would with a regular web software as a service. The initial technology is BigchainDB, but as time goes on, we're going to be generalizing the protocol so that other people can be building other implementations. And by the way, BigchainDB is open source, so you could build your own implementation now if you want. Actually, one person did start working on Java. An implementation there is actually pretty interesting. And overall, and this is the heart, we have this notion of member caretakers. These are the folks running the nodes. They're also doing the governance. The caretakers are the heart and soul of IPDB, the heart and soul of Interplanetary Database. So so let's talk about these caretakers. We actually chose them. We actually know their identities. So we're not trying to solve for Sybil tolerance. Sybil tolerance, it's this problem of attack of the clones, right? If you want anonymous participation in the people running the server nodes, then you have to have some way where someone can't make 10,000 copies of themselves and then they get 10,000 votes, right? But if you actually know the identities, then you don't need to solve for this problem, right? So proof of work basically addresses it by saying every electron you spend is a vote, right? In our case, we say, well, guess what? There's people out there that we would love to have run these nodes because they have long-standing reputations, like Brewster Kahle at Internet Archive. I'd trust him to run a node, sure, right? And Internet Archive in general, it's got this, they're basically a freedom fighter of the internet, right? And not only that, what about Open Media Foundation? What about Dyn.org? There's a lot of folks out there, a lot of organizations that really, truly, fundamentally care about the future of the internet and have demonstrated it over years and decades, right? Also, though, there's a couple other constraints. One is at least half have to be nonprofit, and there's a reason for this. ICANN. And if you think about ICANN, what is ICANN? ICANN is the governance for the DNS. The DNS is a global database powering the internet, but only a very small scope, right? Just the mapping from domain names to IP addresses, right? And the challenge is that ICANN, it was rolled out with very good intentions, and we actually get advice from the people who rolled it out, Jim Wright and David Holtzman, their advisors, and they're sad, and they're very sad, actually, because ICANN got captured by dollars. This is why you can go to a certain domain registrar and buy .sex. Why should that exist? Well, I can let it go through, and now we have basically these the people running .sucks going to Microsoft and going to all the big enterprises who have to spend $10,000 to buy .sucks. Also .bank, right? So, you know, $10,000, it's not $10, it's 10,000, right? So basically the point is ICANN got captured, despite the best intentions. Also another challenge is, you know, you don't want to be captured by jurisdiction. You don't want any one country to be running a majority of this, whether it be China or USA or otherwise. So those are some of the constraints. Overall, these are the caretakers we have, the initial caretakers for IPDB. We've got Blockstack, which is a non-profit open source platform for blockchains. Koala, which organizes workshops and around blockchain and governance, basically. Dyn.org, it's an open source shop. Internet Archive, probably don't need to explain that one. Open Media Foundation, it's about media and the net. Unmonastery, this is actually a really great one. Unmonastery is working with monasteries. They actually, if you think about it, what are some of the oldest lived institutions on the planet, right? Well, monasteries, monks, they dedicate their lives to God. The ones in Belgium to God and beer, which is so awesome. And overall, basically, they're very long-term thinking, right? So what Unmonastery is doing actually is working with these different monasteries throughout the world of many denominations to help bring them into the digital era, to help the monks get online and communicate and so on. So they are Node. Also, we have brought in for-profit, and the reason we have is these are the folks largely who are building the pieces of the next generation decentralized stack, right? So there's us, Ascribe and BigchainDB, Consensus, one of the bigger Ethereum spin-offs, Eris, now Monax, Protocol Labs, that's the guys building IPFS, the decentralized file system, Smart Contract, one of the leading smart contract companies, Scenario, another Ethereum-like company that has figured out formal design upfront, basically, and Tendermint, which is one of the other blockchain companies that has a really nice consensus algorithm powering Eris. So overall, these are the caretakers so far. We actually have designed rules for adding more. So we have governance meetings and all this. So there's a very well-defined rules about adding more caretakers, about removing them, and so on and so forth. It's all transparent, etc. So this is how the governance works, actually. The caretakers do two things. They can vote other caretakers in and out, and they also operate the validating nodes. So those are the two main roles. And actually, they vote others in and out. They also vote for the board of directors, which can operate on a faster time scale than the caretakers. And then finally, the board of directors hires day-to-day management, which operates on a faster time scale yet. So this actually is not a revolutionary design. You might recognize it as how often nonprofits or co-ops are run, or even corporations, where each caretaker would have one chair. The difference is that the caretakers can vote other caretakers in and out, and the caretakers are also taking an active role in running this thing. So we thought a lot about this, right? We've iterated with a lot of lawyers on this, a lot of engineers. And you know, when we first announced IPDB in June, it was when the DAO had raised $150 million and hadn't been hacked yet. In fact, the speaker right after me was Christophe, and he was talking about the DAO. And so lots of people were like, Trent, why don't you make a DAO? I'm like, walk before you run, right? This is hard technology. We think DAOs are really cool, but we don't want to try to solve that problem too, right? So we're using old school technology in the form of contracts that has been around a long time. And as time goes on, IPDB will leverage more and more of these emerging tools of decentralized governance, whether it's Colony or otherwise, right? And that's what IPDB is about. So that's a summary of these two pieces, IPDB and BigchainDB. You can, of course, use BigchainDB in private deployments. There's lots of people doing that. And I think it's very exciting as well. I just have a particular place in my heart for IPDB because it's really the heart of the public internet to help change society on this broad scale. So some use cases. I'll talk especially a bit about ones in intellectual property and ID. If you have questions, I'll talk more later. So Resonate, this is a company based out of Berlin that is basically a decentralized Spotify. So it's the vertical of IP, it's around music rights. It's actually a co-op itself. And you know, it's a streaming service then that's owned by all. So there's dozens, I think even hundreds of labels now signed up to Resonate. Really cool company. And they will be using IPDB. We also developed actually an IP protocol, us with about 10 other organizations. It's called Koala IP Protocol, C-O-A-L-A IP. And that's actually going through in process right now with things like Open Music Initiative and Mycelia and Ujo and Resonate, all the stuff related to music as well as other verticals. Another example, this is where we started, of course, which is Ascribe. So we shipped this in, we started work on this in 2013. We did beta in 2014 and shipped it to the public in February of 2015. And basically, its main target was digital artists. So someone who creates a GIF or a movie and sells it to museums and galleries. Maybe a $10,000 GIF, maybe a $10 GIF, right? And so this is an example of a COA, a Certificate of Authenticity. And it's a modern one, it's a crypto one, right? So basically it's digitally signed and all of that so that it can't be tampered with. And Ascribe, by the way, there's about 5,000 artists using it. Usage is still growing. A couple dozen institutions use it in various ways, museums, galleries, archives, etc. And we're in the process of converting this over to be using IPDB as well. We're quite excited because we see that all the archives of the world in museums, etc., they've spent hundreds of millions of dollars digitizing their work, but they don't really have a way to maintain it and share it with the globe. And we see that Ascribe can play that crucial link from how the museum's practice is to IPDB. And IPFS, of course, too, or one of the other decentralized storage. Authentique, this is an identity company. And there's actually quite a few identity companies as well working with us. This is just an example. Overall, they're about low friction assurance with a roadmap towards sovereign personal data. And overall, right, there's a lot of stuff happening in identity. It's sort of like this sleeper thing that it's hard to realize that it's really its own vertical, but it is so important. Without identity done well, you actually can't transfer large amounts of value across networks. And what if you don't have enough of a, what if you can't KYC because you don't have a passport, for example? You're a kid in rural India. What do you do? So there's actually paths there too for identity assurance. So there's a lot of amazing startups out there doing really cool things towards identity assurance and overall towards things like sovereign personal data. So taking back, what's your personal data inside Facebook, owning that yourself and only doling a little bit of permissions at a time for Facebook to use or otherwise. When I walk into a bar in the USA, they don't need to see my name and my address and my nationality. All they need to know is that I'm 21 or over, right? That's how things should be. Another one of my favorite examples is BenBen. They are doing a land registry in Ghana. And land registry is an interesting one. You might think, well, that's kind of boring, but there's some theories out there that I think are great theories, where having title to your land, if you're poor, is the bottom rung of the ladder to climbing out of poverty, right? And in a country like Ghana or other countries where governance is very shaky, the overall government is shaky, what if your government disappears tomorrow and they burn the land titles? And this actually happened in Crimea. Friends of friends, they actually had some land in their family for generations. Along came the Russians, and there goes the land, right? It actually all got burned, right? If this was actually on a public blockchain, that database, a planetary database, stored in this immutable fashion, then it doesn't go away. It's actually also useful to the governments themselves that don't have great digital capacities. So BenBen is working with Ghana and other governments, actually. Here's another one, education credentials, right? So imagine that I decide that I want to get a job as an astrophysicist. So I put on my resume that I have a PhD in astrophysics from MIT. Well, I apply for a job and the people who are looking to hire me are very excited, but they're going to have to call up and call MIT and figure out, is this actually true or not, right? And it's not a big deal if it's just one person, but what if there's 500 applicants? This starts to get very expensive, right? What if there is a way to demonstrate very cleanly that I actually have that PhD from MIT? Actually, my PhD is from Leuven in Belgium, and in engineering, not in astrophysics. But anyway, it's an aside. My brother is literally a rocket scientist, actually, so I'll stop there. So Recruit, what they're doing is saying, let's put these education credentials onto this global blockchain database and make it so that the cost of verifying identity, education credentials, is much lower. And Recruit, incidentally, it's a $10 billion Japanese conglomerate. So this is not some little small fry. This is actually like one of the largest corporations in Japan. RWE, largest utility in Germany. And there's actually a lot of projects that they're working on. The guy who's running blockchain within RWE, his name is Carsten Stoker. Fantastic guy. He's been running several projects for more than a year now. And really the core is, to kind of summarize across these projects, is energy deregulation. What does that mean? It means that the middleman is going away. RWE was used to generating the electricity and playing middleman to people buying it, right? But in the face of deregulation, then they no longer get to play the middleman, and others can even play the generators. So they actually are facing an existential threat, right? What are they doing? They're getting ahead of it, right? They're actually experimenting with things and trying out different technologies, different products, different ideas, and seeing what makes sense and what doesn't, so that they can get ahead of this. So it's basically classic innovator's dilemma, but they're taking it full force. So we're working closely with them. Tangent 90, this is a fun one. This is actually about transparency in the medical supply chain. So basically, there was a flow of dollars from big pharma and big publishers to doctors, but not dollars in the traditional form, but more of free vacations in Hawaii for conferences and so on. And how do you, if you're a doctor in the UK, how do you get this free conference in Hawaii? You have to choose the drug from that particular big pharma, right? So this, of course, is a problem. So the UK passed an act called the Sunshine Act. And the act says all the flow of value among hospitals in the UK, from doctors, et cetera, among the big pharma and among the publishers of medical journals has to be transparent. Perfect case for blockchain technology. And this is what Tangent 90 is rolling out. So Tangent 90 is people who have been in the industry for 20, 30 years, and they're rolling this out working with the big pharma and the journals and the UK hospitals. So I'll start wrapping up now. We started with this challenge that current systems of power are creating unequal outcomes, whether it's for intellectual property, with creators getting compensated, whether it's for identity, with data silos of our data, or for the unbanked and so on. But we have this thesis that technology and governance, it's really key to add the governance, designed appropriately can help communities build a more equitable society. So together, right, we're building this decentralized compute infrastructure and these applications. It's not just us, right? We're building an essential piece. We're building the database, right? But there's lots of other fantastic people out there, fantastic organizations, building many other pieces. The IPFS folks, the Bitcoin folks, the Ethereum folks, the Hyperledger folks, and so on and so forth. This is something we're doing together as a community. And it's very exciting. We're changing the world. So that's what we're building together. And from our perspective, a way to summarize this is achieving planetary scale trust that leads to human scale development, right? Developing for humans at a scale that is at this very broad level for personal data, for compensated creators, and more. And I will stop there. Thank you.
Questions?
So just to clarify, can I or anyone else just connect my computer to this and drive the network and get some sort of coins or dollars or so back?
Nope, definitely not. So a few things. BigchainDB, you can go to github.com and download it right now. It's open source, AGPL. IPDB, we are slowly rolling it out, okay? So when it is rolled out in its full instantiation, you will be able to connect to it and write to it and read from it. And you will be able to have full transparency into what's going on. What you will not be able to do is validate other transactions. That is just for the subset that is the caretakers. In contrast to, say, Bitcoin, where you need to spend $50 million to actually be able to validate a transaction to have any chance, right? So yes, anyone can theoretically join Bitcoin and be a peer, but it actually means nothing in a practical sense. So the big, the difference between theory and practice is practice. So our view is, we have this public network that, just like Bitcoin or Ethereum or any of these, you can read to it, you can write from it, and you have full transparency. And then there's just different levels of, what's the criteria to be able to validate transactions coming through. Tario?
Yeah. You talked about how BigchainDB was based on RethinkDB.
Yes.
And now you're migrating towards Mongo.
Yeah.
Can you talk a little bit about the pros and cons that you saw with Rethink?
Sure.
And what led you to?
Yeah, sure. So overall, our vision is that there's going, 2 years from now, 3 years from now, there's going to be like 10 or 15 database backends. When we initially started working on this, we actually evaluated 8 different databases. So Cassandra, HBase, React, RethinkDB, Mongo, and all of them, of course, scaled like crazy compared to anything in the traditional blockchain world, right? So it wasn't about scale. They all had querying too, of course. The big difference then was simply which could we build faster, sooner, to get something out to demonstrate, to iterate against. And it turns out that Rethink was the easiest to work against. Why? It had, a couple of them have a global change feed, and it had the best. So a global change feed basically means that anytime any one of the nodes gets a transaction coming in, it reports that to all the other nodes. So basically, you're getting order all the time. Every single one of the nodes always getting order. So from that, we could actually build out the infrastructure, like BigchainDB itself, faster than using the other technology. MongoDB, by contrast, it only has something they call their oplog, and that's on a per node basis. So it's actually more difficult then to get one overall global order. We actually have a technical solution to that we're implementing right now, and that's why we didn't do MongoDB at first, basically. The other sort of difference why we're migrating is MongoDB is basically has more mindshare, has more market share. And RethinkDB had been around almost as long as MongoDB, but it got acquired about a month ago, or acqui-hired by Stripe. So the team is still maintaining it, but there was like 15 people in Rethink. There's 500 in Mongo. So yeah, MongoDB. If you tell people in banks, etc., about it, they're like, oh yeah, we're already a customer. You tell them about Rethink, and they're like, what? So it makes our life easier. But like I said, as we're architecting building in MongoDB, we're actually doing it such that we're keeping support for Rethink. So that way there's a pattern for people to have, they see Rethink, they see Mongo, and if they want to build their own favorite database backend, they can as well. And actually, frankly, when we see the other decentralized backend storage engines coming to maturity, we'll be happy to plug those in too. Things like when Scenario gets more mature, when there's 5 or 6 different Ethereum projects related to scalability, right? 2 or 3 Casper variants, etc. So when those get more mature, maybe they can plug in too. And otherwise, right? So we're not religious about what that backend is, but as we're shipping, we really have to focus on having one very, very good stack top to bottom. So we're really focusing on that. Yeah.
Who's taking the decision? Who becomes caretaker, and what are the criteria?
Yeah. So I can go back to here. So we had a sort of kickstarted ourselves, right? And at first, it was me and the person who runs IPDB, Greg McMullen. Actually, there's a third now too, David Holtzman, the guy who was the technical architect of the DNS. So, and he's been an advisor all along. So basically the 3 of us, Greg McMullen, a lawyer by training, and actually a privacy rights advocate, David Holtzman, DNS architect, and myself. And we were just saying like, who would be awesome, right? Which organizations would be awesome? And then we wrote our own sort of list, and then we reverse engineered it and said, why, right? And then we realized it came down to these things here, right? So long-standing commitment to the decentralized internet, at least half nonprofit, and fewer than half in any given country. These are some of the criteria. Now, basically, what the process will be, IPDB has a rollout plan of over 6 months, 9 months, right? And so that was the initial criteria. But as it rolls out, then anyone will be able to submit saying, hey, I'm interested in doing this. Here's my proposal. And then the caretakers themselves will vote on this, right? So we had to kickstart it with just the 3 of us. But it's basically these 17 nodes, they're the ones who control it now, right? Or they will, right? So, and the essence of the rules is that. It's actually, there's a much more fine-grained list, but this is really the core.
And how many are they at the moment?
17, yeah. And the overall plan is adding 20 per year for the next 5 years. And then ultimately our aim is, we would actually love to see it where any peer can join without having to be vetted at all. And it becomes a server-free decentralized architecture rather than server-based. The problem is right now, there's actually a trade-off. You can have planetary scale, consistent database, consistent enough to prevent a double spend, and server-free decentralized. Pick any 2, right? It's actually a new triangle, right? I call it the DCS triangle. So decentralized, internet scale, planetary scale, and consistent. So for example, IPFS actually it can't prevent double spends, right? But it's actually got the other 2. It's got the planetary scale, and it is server-free decentralized. Ethereum and Bitcoin, they are consistent, they prevent the double spend, and they are peer-to-peer decentralized, like server-free decentralized, but they are not scaling right now, right? So we have a plan towards that, and this is why we will be overjoyed to leverage that technology as they develop it. Stuff like a backend that is fully peer-to-peer decentralized, fully server-free decentralized rather than server-based. So I hope that answers your question.
Yeah, partially.
Sorry?
Partially.
Partially. What did I miss?
I wonder how this plays out in the future if regulatory body starts getting interest into it and start having influence on it. How do you think this is going to play out?
Yeah, well, this is why it's really, really important that fewer than half can be in any given country. And I think we've even changed it now. I think it's 30%. So any country can't have more than 30% of the nodes. And it's really important because if you get pressure from like the USPTO or from the Chinese government or whatever, and you've got like, 60% of your nodes in the US, it really messes with things,
So
right?
what was the process to change the rule from going down to 30% coming from home?
Oh, we just realized that we could make it more diverse yet, right? Who?
This
No, in this case.
17 or-
So overall, right now, it's in its formative stages. So we've had a governance meeting. And in this case, there was about 12 people in that room. And it was basically like 12 of the 17 caretakers that were making those decisions. But as we slowly roll this out, then it's going to be turned on fully in the next 6 months, 9 months, where it's only votes by the caretakers, right? But you have to kickstart it somehow, right? So you want to have a good trajectory to start with. One other thing that we really care about is we see that eventually the governance technology will get mature, and peer-to-peer decentralized will get scalable. As that happens and it becomes clear, then it's our hope for the foundation itself to dissolve, to go away. So it might be 10 years, it might be 20 years, we don't know. But this is part of the point there is, the longer it runs, the longer the chance that it has of getting captured, right? So to us, it's really, really important to give this to the planet as best as we can, right? And that's also one of the motivations for, instead of just having 17 caretakers, to add 20 per year, right? On this rolling basis. So we're really, we're working with a lot of constraints that we're trying to balance between what's the technology capable of now, what's the roadmap, what are the different ways you could get captured. And we believe that, we're very proud of the design. We think it's very pragmatic and it means that we can ship a planetary scale database now that still has a path towards full peer-to-peer decentralized.
And how do you see the incentivation so that you will become a caretaker?
Yeah, so actually, and I didn't answer the question before too, there are no native tokens in the sense of to help power it. And this is very different than all the other token-based networks. Instead, basically for a node to keep running it, so overall, IPDB is a non-profit German foundation, okay? And which means that it actually can't make a large profit any given year. It just has to have an operating balance, that's all, right? And so it only takes in enough money in order to pass on to the caretakers to cover their costs, right? The caretakers are getting their costs covered, and it's just worth their trouble, no more, no less. And if they're not incentivized by doing this thing for the internet, then go away, right? That's part of the point. This is not a way for them to get rich. They'll never get rich off of this. They're doing this because they think that it's helpful to the future of the internet. Right.
Fair point, but even to get the current cost base running, you need to suck in some money.
No, you don't. Think about it. If I'm running a web service right now, right? I'm running Heroku. I'm running on my own servers or on Amazon servers, and you're doing transactions on me or my client, and maybe you do 10,000 transactions a month. You're paying me 100 euros a month. Done, right? It's paying for itself, right? So this is the point. So basically, when people are using IPDB, they're going to pay, whether it's in Ether with smart contracts, and this is part of the roadmap, or otherwise, get a receipt that says, now I have 1,000 tokens or 1 million, I paid for the next 100,000 transactions, right? And then it knows my identity when I'm paying as a client, and I'm good to go. So it's a myth that you need a token-based network in order to be decentralized. And actually, I think it's even, a lot of it is sort of captured. If you do have a token-based network, then you have a lot of greedy folks coming in, right? So we're actually trying to explicitly avoid the greed and instead, really be strongly nonprofit. And we don't care if we're doing something exactly different than everyone else. We believe this is right.
Do you have any use cases where smart products are using our database?
Smart product?
Yes.
Could you elaborate on what smart means? Because there's depends on the field.
IoT-enabled products.
Yeah, so overall, some of the applications within RWE are like IoT-ish because you've got the energy meters and all this.
Yes.
Some of the other ones also, the identity-related ones, they tie back and forth to IoT for identity verification. So there's a lot of there's so many we can't keep track anymore, but yeah, there's that. And also, I didn't really emphasize it here. It is used in the enterprise. Banks are using it and this sort of thing. And we're excited about that. I'm doubly excited about the public one. So that's all.
I understand that the support network is very limited, like we said before. Can someone, though, help in that sense, maintain the network by relaying read and write queries? And what about the physical storage? Where is that?
Yeah, so each node running the network actually includes the physical storage, right? So if you think about a database, it's actually sitting on top of a file system, which is sitting on top of a physical hard drive, right? That's all within the same node, right? Just like right now, if I'm running a MongoDB cluster, right? Each one of the nodes in MongoDB has, there's the MongoDB software running on the file system, running on the physical hardware, right? So it's the same thing. You don't have to have like storage or IPFS below. You could, but then actually latency will screw you, right? Like it's just not possible, and it's not going to get better anytime soon. To your other question then, is there ways for other people to help? I imagine that as time goes on, as IPDB gets rolled out, people will identify bottlenecks, and then they will start building infrastructure on top to help, right? And maybe there's ways at the core. For example, there's probably going to be an emergent market for caching, local caching. IPDB being global, there's about 4 messages that have to go back and forth before you have consensus, right? And in those 4 messages, you're talking about a second of latency then, right? So in that 1 second of latency, that could affect the user experience. So if someone had a service towards more local caching for higher speed, and then more, for global consensus, it takes a second, there's value in that, right?
You said a node, though. Is that one of these caretaker full nodes validating or not?
Yeah, so every caretaker is running a node, yeah, like a physical node, yeah.
But is that enough to scale from a bandwidth and storage space? If you said to add 20 a year or so?
Yeah, so there's actually a few different ways to scale. One of them is each of these nodes, they can be running on the cloud services, right? They can be running on Azure or Amazon or otherwise, or their own physical boxes, those who have the capacity like Internet Archive, right? So within something like Amazon, there is elastic file system, and what that allows you to do is it means you can actually store not just terabytes, but hundreds of terabytes on a single file system, right? And it looks like a single file system, and that's actually how you scale. MongoDB itself also has extremely good horizontal scaling, right? You can add hundreds and hundreds and hundreds of nodes. So those are the possibilities for scaling. And actually also beyond, let's say that the database really does get full somehow, then we envision actually that there can be multiple databases running side by side, multiple instances, if you will, connected by interledger. So there could be like version 1 that takes a year to fill up, and then version 2 that takes half a year, and then from that time on, maybe it's another database every month or something that gets filled up if it's really at scale. But that's okay because you have interledger that connects these networks, right? It's a TCP/IP of value. So and we work very closely with the Interledger Foundation. We're one of the 3 W3C chairs of it. So this is actually a key thing for us. And BigchainDB itself speaks natively the language of interledger. So really those 3 things overall for scale, so the elastic file system part, MongoDB horizontal scaling, and then multiple networks of BigchainDB instances at once. David?
Thank you very much for the presentation. But I got a bit confused with the stack representation you showed.
Yeah.
How does BigchainDB and IPDB play together with Ethereum or Hyperledger?
Yeah.
Is it just a representation like smart contracts on top of BigchainDB, or how do you solve the
Yeah, there's a few different options, and so overall, like Ethereum is what's it really good at? The interface to Ethereum is a programming language, right? Which means that you're actually writing code, and so it's really about processing then, right? That's what code is for. Versus with a database, you're writing queries, so it's really a different interface. So if you think about, ignore decentralized stack for a second, if you're building an application, say a web app or something, you're going to have some code running in Django, maybe running on Heroku, that is talking to a database, but that code itself is running on its own thing. So one of the ideal interfaces, ideal for me, is actually Ethereum, like Solidity, is actually natively calling IPDB. That's not possible right now because it requires a change to an opcode, but you can actually go through something like Oracleize to get it, right? Now, of course, if you're using Oracleize, that means you actually have to copy and paste that data into Ethereum, and it could choke Ethereum, but MongoDB has aggregate queries, and this is a key. So as an example of a use case of a company we work with, it's actually the billing, like electric meter billing, 50,000 transactions a second going into BigchainDB, but then once a month you actually have to figure out the bill for the user. So that can be from Solidity doing a query to BigchainDB, saying, give me the sum of all the power usage in the last month, right? So that's an example where aggregate queries are a way to make it work. As time goes on, you can also do it where you can have Ethereum running here and you can have BigchainDB running here side by side, right? So, and that's not so bad. You can also have it where it's running on your client in JavaScript, right? So, because if it's running on something that you control or you own as the client, then that part doesn't need to be decentralized, right? Because you control it. You know, if it's running on my mobile phone or if it's running in my browser, then I can talk to Ethereum and I can talk to IPDB on its own, right? So there's several options. I'd say there's no perfect interface yet, but we're very interested in exploring all the different ways and encouraging people to iterate with us on it.
Do you have reference cases already?
Sorry?
Do you have reference cases with such a...
We're just in talks with various folks. I don't know of any directly that have fully implemented, but to me, like, it's a software engineering problem. Like, you just connect this with this, right? And we're also in talks with people at the Ethereum Foundation about like actually making BigchainDB more first-class citizen. But it's BigchainDB and IPDB are not mature enough yet, so it's not really worth having that discussion in a deep way yet, right? Yeah.
I was curious about the caretakers. I guess you're putting a lot of trust in them.
Yeah.
And I'm wondering how much transparency there is as to their performance and.
Yeah. So overall, we will be we are building a dashboard for the overall network performance. Just like, you know, on blockchain.info, you can get dashboards for the health of the Bitcoin network and what each individual node is doing. And Ethereum has dashboards and so on too, Zcash, all of these. So we will be having something like that for IPDB. And there will be drill down statistics too, down to the level of things like New Relic, where you can see very detailed things going on, right? So, and overall though, part of the point of decentralized, there's another definition, and that is no single point of failure. And once again, it means you don't have to trust any single given caretaker node, or even you know, maybe 3 or 4 are being malicious or being hacked or whatever. That's okay. Right? And if you see that's something weird is going on, then action can be taken, because you've got the managing director who's looking, you've got the board of directors, and ultimately you've got the caretakers themselves. Right?
Last question.
How much power is it going to use?
So overall, the way to think about this is it's a database, right? So how much power does MongoDB use, right, to store, you know, 100 terabytes or a petabyte, right? So it's that, but then of course you've got, and MongoDB of course has replication factors of 3 or 5 or 7. This would have that, you know, 3 or 5 or 7 or 10. So it's roughly comparable to that. Remember, there's no proof of work here, right? Proof of work is only there to solve the Sybil attack problem, the attack of the clones problem, right? So in the case, you know, here, rather than using up the electricity of Ireland to store 70 gigabytes, it's using up, you know, a fraction of a data center to store petabytes, right? But like, Bitcoin has a role in this world, right? And it's actually as an e-gold, as an e-cash, and I think Bitcoin is really cool, right? It's just not a very good database. Another thing that I really want to clarify, because people often ask me, so where do I store the hash? And the point is, you don't have to store the hash, you're storing the data. That's what a database does. A database stores the data, right? In this case, it's a document store, like JSON, structured text, dicts, all that, right? So no hash needed, right?
Thank you. So as usual, Apro is in the back, sponsored by Swisscom. Thank you. Grab some beers. And yeah, take the time to speak to Trent and get more of your questions.
There's stickers too if you guys want.
Yeah, cool stickers.
Yay, stickers.
For the nerds.
Yes, exactly. Thank you.
Great. That's really cool.
I kept giving little nuggets for the nerds. But
No, yeah, you never noticed it.